Welcome back. Today we're going to look at question answering, one of the oldest applications in natural language processing. Some of the first NLP tasks built on punch card systems in the early 60s include the Simmons et al. System from 1964. Let's look at that. So that answered questions like, what do worms eat? By taking the question, parsing it into a dependency format, so we have a relationship between eat and worms and eat and what, and then looking for a matching dependency sentence somewhere in a large database of answers. So they had sentences like worms eat grass and birds eat worms and horses with worms eat grass and so on. And the idea is that this dependency treelet, worms eat what, matched worms eat grass, and even grass is eaten by worms, but not horses eat grass or birds eat worms. So the idea of answering a question by finding a sentence that looks like the question but answers it is an old intuition that we're going to see underlies many modern systems as well. You may know that last year IBM's Watson won the Jeopardy challenge, answering questions about, for example, this Bram Stoker novel that was inspired by William Wilkinson's book. So the novel, of course, was Dracula, and the author was Bram Stoker. You may also know about Apple Siri, another question answering application. So you can ask questions like, do I need an umbrella tomorrow in San Francisco? And it will check the weather for you and tell you which days it's going to rain. Another question answering application, Wolfram Alpha, you can ask questions like, how many calories are in 2 slices of banana cream pie? And not only will it give the answer, but it'll give you little variables that it'll tell you the semantics of the answer. So we're looking for an amount of pie that's 2 slices of banana cream type, and we're asking about the total calories, and there's the answer, 702 calories. So these kind of questions are factoid questions. So questions like, how many calories are there in 2 slices of apple pie, or who wrote the Universal Declaration of Human Rights, or what is the average age of the onset of autism? These kind of questions, pretty simple questions, can be answered by a simple fact, often a named entity. Modern systems also deal with complex or narrative questions. So in children with an acute febrile illness, what is the efficacy of acetaminophen in reducing fever? Or what do scholars think about Jefferson's position on dealing with pirates? So these complex questions are generally answered more in research systems, whereas factoid question answering is a widely used commercial application. What are these kind of factoid questions? So they can be questions about locations, so the Louvre being located in Paris, France, or what an abbreviation means, or the names of the ravens of Odin, names of a currency or an ingredient, or an instrument or a phone number. So they're all simple answers, often with a single phrase or named entity. There are 2 main paradigms for question answering. The IR-based approach, which we'll spend a lot of time on today, and that's pioneered in the annual TREC evaluations and used in commercial systems like IBM's and Google's. And the IR-based approach is go find the answer in some string on the web. The knowledge-based approach is build an answer from understanding a parse of the question, and hybrid approaches take a combination of these approaches. So we might use some online databases, and we might use some information retrieval approaches to find sentences and build answers. And most modern systems, I would say, are some kind of hybrid of knowledge and information retrieval. A few of them, like perhaps Wolfram Alpha, are purely knowledge-based, but most systems use a little bit of both. So simple web search actually answers a lot of questions already, and that's really the intuition underlying the IR-based approach to question answering that we'll talk about the most. So if I asked into Google, what are the names of Odin's ravens, the first page I get has the answer, and in the snippet that Google returns, there's the answer. So it's in the title of this page, and it talks about the names of the ravens. Other kinds of simple questions like where is the Louvre Museum located are also answerable by methods like Google. And here, in fact, Google applies modern question answering techniques to give you its best guess for the location by pulling it out of semi-structured resources like Wikipedia or Answers.com. So let's see how this factoid question answering algorithm works. The general algorithm for IR-based factoid question answering starts with a question and begins by extracting information from the question itself. And the two most important and common things to extract from the question are a query that's going to be sent to an IR engine and the type of the answer that tells us what kind of named entity we're looking for. In advance, we take a whole lot of documents, we index them so that when we have a query, we can return a whole lot of documents. From those documents, we extract passages, so parts of those documents, and then those passages are then processed in answer processing, looking for the type of the answer that we know we're looking for, and then returning an actual answer. So that's the general process, and we'll walk through each of the pieces today. So another way of looking at the same set of processes, three big parts of the algorithm. Question processing, so we're detecting the question type, formulating the queries. Passage retrieval, given these queries, retrieve documents, break them into pieces. And then answer processing, extract answers from the text snippets and rank those candidates using evidence from the text and from other kinds of sources. So by contrast, the knowledge-based approach, which we'll talk about less today, builds a pure semantic representation of the query. And this is true of Siri or Wolfram Alpha, where they're going to come up with a semantic representation language for questions that they understand. And you might pick some subdomain that you're able to build a perfect semantic representation for. Times, dates, locations, scientific questions, mathematical questions. And from this semantics, we can then map to structured databases or structured resources, geospatial databases or ontologies or restaurant review systems. These things where we can build a pure semantics of the approach. Hybrid approaches, and IBM Watson is a good example of this, but lots of others do this now. Build some shallow semantic representation of the query, so they do some processing of the query, use IR methods to generate many candidate answers, but then use these more knowledge-based approaches, geospatial databases or temporal reasoning, to score the candidates. So IR methods to find possible candidates, knowledge-based methods to score them. So question answering is both one of the oldest topics in natural language processing and also one of the newest and most exciting research areas with commercial potential.